Hello everyone and welcome to this training session on statistical data analysis using SPSS. My name is Vamsidhar. As a part of this session, I would like to cover the relationship between two categorical variables. Till now, all the earlier sessions which we were discussing, the major discussion was on analyzing variables independently, each variable separately. But our intention slowly has to move towards taking two variables together, analyzing the relationship between the two variables, and bringing out some kind of statistically significant relationships, if at all they exist, between the various groups of variables. So as a part of that exercise itself, we are starting off with the first of that kind, called as a cross tab analysis, wherein we will do an analysis taking two categorical variables together. Alright, so just trying to find out if there is some kind of relationship existing between those categorical variables. So categorical could very well be your nominal variables or even ordinal variables. So how do we get about with that? Okay, just to give a quick summary before we implement that relationship in SPSS, the major business requirement or the business scenario which we would be looking at while doing a cross tab analysis is you are looking at the relationship between two categorical variables, and if possible we'll do a layering by additional variables also. What does that mean? I want to find the relationship between A and B. A is one categorical variable, B is one categorical variable, but this relationship I want to observe separately for each of the values of C. So probably let's say C is nothing but a gender, another categorical variable. A is some categorical variable and B is some other categorical variable. I would like to find out the relationship between A and B separately for males and separately for females. That is what we call as a layering. Overall, if I am trying to find out the relationship between these two categorical variables, it's at a high level. But if I am digging down to find out the relationship between A and B separately for each of the elements of C, that is what we call as a layering. So if required, we can very well do the layering also and base our relationship analysis between the two variables A and B using this cross tab procedure. So in this chapter we would be dealing at length with this kind of scenario, and what we are also saying is it even tests for the independence. There is a statistical test also which it offers, saying is there a relationship between these two, or are they statistically independent? Is there a statistical relationship between these two, or are they statistically independent? And it even measures the degree of association between the two variables. In case they are related, how strongly or how weakly they are related. That is one more aspect that we can derive using this cross-tab analysis. And at the same time, in the next session, I would also take you through an example which will deal with identifying the relative risk of an event. Sometimes in a statistical world, we also call it as odds ratio or relative risk of an event. What is the chance that event X occurs as a proportion of event Y? That is what we typically call as relative risk. I'll take up an example in the next session, and we can make some kind of conclusions on that. So all these various things can very well be performed using the crosstab analysis in SPSS. So to demonstrate that in SPSS, I have considered a few case questions. As you all know, the case study remains the same. The data which is associated with the various people, male and females, their educational smoking status kind of thing, and apart from that, some quantitative variables like height, weight, waist, pulse rate, and a lot of other things like that, which we have been using for our other calculations. Here, remember, when we are doing the crosstab analysis, I need the relationship between two categorical variables only. So in our data, there are four categorical variables: gender and marital status, which are nominal, as we have already discussed, whereas smoker status and education category are ordinal data in our. So we will use both of them. So for that purpose itself, I have taken one case question saying, is smoking status uniform across all marital status? Means if we see here, smoking status is more of an ordinal variable, marital status is more of a nominal variable. So I have one ordinal and one nominal here. Whereas in the second case, is smoking status uniform across all education levels? So both of them are ordinal variables. So I want to check if there is completely independence, means the uniformity exists across all the education levels, or probably I would like to know whether highly educated smoke a lot, or less educated people smoke a lot, or is there any kind of such relationship existing between the smoking status and the education level. And finally, we are even bringing in the layering by doing it separately for each gender. Initially, I will do it uniformly across the whole set of data, but after that, I would like to handle it separately for male and female to see if the relationships differ between the male and female as far as the uniformity of the smoking status is concerned. Alright, so we'll try to address these questions from our data. So let's get started with it. So first thing, I'll try to do the relationship between this categorical variable and this categorical variable. One ordinal and one nominal. So for that, let me start off. I'll go to this analyze descriptive statistics cross tab. So cross tabulation is asking for rows and columns. Probably I can consider the smoking status, doesn't matter. Smoking status I consider in columns, whereas the marital status I consider in rows. Doesn't matter, you can do it the either way also. But some of the important things that are required here, not just the calculation, probably if required I should look at this graph. This graph is nothing but the clustered bar chart, we'll look at it. But one of the most important things I suggest is the statistics, where we look at the chi-square. This is a test which actually gives us whether these two variables are independent or some kind of relationship exists between these two variables. That is what is typically given by this chi-square test for the independence between the two variables. So that's the reason I would like to go with a chi-square test. And because I have a nominal variable with me, I would try to check for these things. These are some of the variables, or these are some of the calculations which give me an indication regarding the strength of the relationship. We'll discuss all these, but just on a broad scale, this will tell me whether the relationship between the two variables exists or not, which means whether the two variables are independent or not. Whereas if they are really dependent, what is the strength of their relationship? The strength of their relationship is what is given by the various calculations. So if at all we have one nominal data in our calculation, I would prefer using these things, and if at all both the data are ordinal, I would go with these things, right? But the way we analyze, I'll come to that. So I'll select these things and simply say OK. So this is what will take us into the crosstab analysis. All right. So this is the crosstab analysis that gets generated. On a broad scale, you could see that there are 400 records between the marital status and the smoking status, means all 400 records are present. So zero missing records. So base case processing summary. But the most important thing that you need to look at is initially the tabulation. The cross tabulation, where it is showing the frequency of each of the status across the various marital status. Now you see single 36, 47, 15. Married 72, 97, 62. Divorce 15, 20 and 9, 10, 15 and 2. These are some of the things we have seen as a part of the various marital statuses, the smoking status. Now I need to know whether the proportions are uniform. At least on a broad scale it is appearing like this is the highest. The occasional smokers are highest in all the genders, whereas the heavy smokers are lowest in all the genders. But I really need to know whether this difference or whether this pattern is more or less uniform in terms of proportions across all the four genders. The proportion of non-smokers, occasional smokers and heavy smokers, is it more or less uniform across all the genders, or do I really see a significant difference existing between the groups? From that standpoint, I should look out for a statistical test. Otherwise, by a simple visual representation, it is showing that there is a significant proportion of the people in these two categories, but very less people in this category. But I need to know that whether that is significant or not. To understand that, I need to go for a statistical test, which is what you see as a part of the chi-square test, because from the cross tabulation, from this tabulation alone, it is very much impossible or very much difficult to say whether some differences that are occurring. Here we are seeing out of 30, only 2 of them are heavy smokers. So probably around 6% of the people are heavy smokers here. Whereas if I look at it here, 15 out of almost 100, means almost 15% of the people are heavy smokers. So there is a difference in the proportion of the various smoking levels across the different marital statuses. So I really want to check it statistically to say whether the differences are real, where some conclusion can be made, or they are purely because of a chance, purely because of that small data sample which we have taken. Is it purely because of chance, or is the relationship, is there a difference in the proportions significantly? And that is what we go to the chi-square test to look at. And what we look at in the chi-square test is, the chi-square test, the way it works is, Okay, these are the observed values. And it also comes out with another set of values called, it also comes out with another set of values called the expected value. And what it does as a part of expected values is, in case the proportions are uniform across all the groups, the proportions are uniform across all the marital statuses, what should be the numbers? What should be the numbers in case the proportions are uniform across all the genders? So from that standpoint, it computes the expected, and based on those two, using some mathematical formula, it will arrive at a chi-square value along with a significance level. As a business user, for me, I'm only bothered about this significance levels here. 0.16. As a business user, that one single word, that one single number will really help me out. 0.16 is the significance number. So compare it with 0.05. So if it is really greater than 0.05, I can very well ignore the fact that there is a relationship between the two. So if the significance level comes out to greater than 5% or greater than 0.05, I can very well say that there is no relationship, means there is a uniformity. I cannot say that there is a difference in the proportions across the genders for various across the marital status for various smoking levels. So which means there is a, I'll go with the assumption of uniformity itself. Though we are saying in reality 2 out of 27 people, a widow, in a widowed category, 2 out of 27 were heavy smokers, whereas in single category, 15 out of 98, the proportions are different. But what we are saying is these differences are not that significant statistically. These differences are not significant, so I can very well go with an assumption of uniformity itself. The moment in case I had got this value less than 0.05, I could have easily made a statement saying there is a difference in the proportions across the various marital status, across the various smoking statuses. But here I don't have such kind of a statement to make. I can very well say that there is a uniformity existing across the various marital statuses for the different smoking statuses, right? So that is one thing. So wherever we see that significance value is greater than 0.05, I cannot say that the differences in the proportions are significant. So I can very well make a very broad level assumption saying there is a uniformity between the two variables itself. There is no significant relationship between the two variables. But however, if I want to break down this analysis, I can do it into much more details, right? But just to move a little bit further, in case we had got this number less than 0.05, in case we had got this number less than 0.05, I would have very well gone ahead looking at the strength of the measures. The strength of the measures are typically given by the symmetric measures. The strength of the relationship is given by these symmetrical measures. Again, here also you see for the symmetrical measures also, we are seeing that the significance levels are greater than 0.05. But if the significance levels are less than 0.05, we could have very well gone further we could have very well gone further and simply assessed these values. Right? Assume that these values are less than 0.05. First of all, the symmetric measure, I'll write an algorithm here. Only if for the chi-square, if the significance less than 0.05 only, then only I will say that there is a difference in the proportions. Means there is some level of relation, there is no independence between the two variables. So some relationship is existing. So that is where I want to find out the strength of the relationship. And the strength of the relationship is measured by the symmetric variables, symmetric measures. Right? So if this is not less than 0.05, I don't need to go with this entire thing at all. But just I wanted to explain that. So when I am doing the symmetric measures, I will first look at again the significance level associated with the symmetric measure. Less than 0.05, then I will look at these values. The higher the values are, sometimes they may even go up to 1 also. The higher the values are, the higher is the strength. Higher the values, there are again different ways of calculating the strength. Right, they are very, the higher the value, this is because this is a symmetric measure, it will be uniform on both the variables. The higher the strength of the variable, the higher the values, the higher is the strength of the relationship. Probably anything like 0.5 and more. For these values, 50% and more is an indicator of the strength of the relationship between the two. The higher the values, the stronger is the relationship. So here we are seeing the values are much lesser for all the three calculations, the phi, the Cramer V and the contingency coefficient. So probably I can very well say that there is no significant relationship. Of course, I would have eliminated the relationship here itself because the significance level is less than 0.05. I don't need to even consider this. And even when I am considering this, it is showing that these values are much lesser, which means they can very well be ignored and finally said that that there is no relationship that is existing. However, if this number had been less than 0.05 and these values are like this only, then I would have said that at least there is a very weak relation. There is a difference in the usage. If these are greater than 0.05, I'll say that there is no relation. Even if the values are small, large, whatever it is not a statistically significant relationship at all. But if these values are less than 0.05, then even if the values here are like this only, I could have concluded that there is a weaker relation existing between the two variables. This is one thing I would like to see out of the symmetric measures. And again the same, if that had existed, we could have even looked out for the directional measures, which typically say if at all any of these values, again you could look out for each of these values, if at all any of these values is much more higher, I could very well say that the variable, by knowing that particular variable, let's say here the value is only 0.01, but if it had been more than 30%, 40%, then I could have easily said that based on the marital status, I can easily determine the smoking status. If this value is very strong, if these values are very high, at least 40-50%, 0.5, 0.4 plus kind of numbers, then I could very well say that by knowing the marital status, I could very well identify the smoking status. That is the depth of the relationship that is existing between the two. It's not the other way. By knowing the smoking status, I may not determine the marital status, but by knowing the marital status, I may be able to determine the smoking status. That is what we'll talk about. Will be talked about by the directional measures. There are three different directional measures which SPSS computes: the lambda, the Goodman and Kruskal tau, and uncertainty coefficient. We are not much bothered about the formulas that they use for calculation, because the tool simplifies the procedures for us. So we need to be able to interpret from the business usage standpoint to make the necessary conclusions. So what we see here typically is, look out for one, the significance levels here also. Almost all of them are greater than 0.05. Only this one is less than 0.05. Marital status dependency, the smoking status dependent on marital status. So if I come and see, the value is much lesser. If this value had been very high, let's say 0.4, 0.5 kind of number, then I could have very easily concluded that by knowing the marital status, I could easily determine the smoking status. That is what we'll talk about: the depth of the relationship as well as the direction, which is dependent on what. That kind of an analysis can very well be brought out. Now in our example, so we'll try out for the other examples because we have three different case questions to address in this, and the last one being a simple graph for single. We are talking, a bar chart is simply talking about the distribution of non-smoker, occasional smoker and heavy smoker across the three marital statuses. Alright. So now what I suggest is, we'll go back and look out for, probably I'll take up this, check the above relationship separately for each gender. After that we'll go with an ordinal to ordinal kind of a mapping. So here I want to find out the same relationship for each gender separately. So again what I'll do the same, I'll pull out the recently occurred one, the crosstalk. This is where I add the gender, the layered by the variable. I can have any number of variables in the layering also. By doing next, I can very well go with any number of variables. So we'll quickly run this test to see, is there anything significant for us? Okay. Okay, let's look at first the summary part. In the summary part, I could really see a different cross tabulation now for male. This is the proportions, or these are the numbers, whereas for females these are the numbers. Fair enough. And these are for the totals, the split across the various smoking statuses, across the various genders. Alright. Now you see the chi-square test is computed separately for males and females again, but even in this case what we are clearly seeing is the significance level is 0.4545 greater than 0.05. Even for females it is 0.08, which means greater than 0.05. So which means across the space there is not much of a relationship. There is a uniformity in the smoking levels across all types of people, whether it is single, marital state, married, anyone. In both in males as well as females, there is more or less a statistical uniformity. There is no statistical difference. There is no significant difference statistically between the marital statuses and the gender and the smoking statuses across the various genders. Had these been less than 0.05, any one of them, for male or female, if it had been less than 0.05, I would have been tempted to look at the symmetric measures Again, in symmetric also I am seeing that these values are greater than 0.05 itself. So I don't need to bother about these values, and I can very well say that these values are merely because of chance, but it's not a very strong relationship existing between the marital status and smoking status, even if I split the data separately for each gender. The same thing happens with respect to the directional also, which is dependent on what? You could see almost all these values are having very less values. Means they can very well be ignored, saying one is not dependent on the other at all. I could very well talk about the independence between the two variables. Now probably if I want to redo this analysis, let's say instead of marital status, I would like to look at the smoking status. If required, we'll reset all of them. So I'll go with the smoking status across various education categories. And here to address it a little bit more, I'll go for the chi-square. But because both the data for us right now are ordinal only, I will select these, which are more similar to finding out the strength of the relationship in case of nominal. These measures the gamma, the Somers T, Kendall's tau B, and Kendall's tau C. All these formulas, they help us in determining the strength of the relationship, if at all it exists, the strength of the relationship between the two variables, and the directional measure also saying whether x is dependent on y or y is dependent on x. Okay, I'll go ahead with this analysis. If required, I'll go with a clustered bar, and probably I would even look at gender wise for here also. I'll add the layering here also. Now let's see. Here what we are seeing, okay, across the various educational levels, these are the proportions, right? 15, 18, 5, 18, 19, 9, 11, 14, 7, 12, 18, 9, 14, 17, 12. So this is the typical breakup right now. And when it comes to the females, 12, 21, 12, 12, 22, 11. These are some of the numbers that are existing across the females. So let's see if statistically there is any kind of a significance. What we are seeing is for males, the significance level is 0.91, much greater than 0.05. So though there is no evidence for me to say that the smoking levels differ across the education levels. So that's not the conclusion. Smoking levels are more or less uniform across the various education levels. So probably I could make a conclusion here. To write a conclusion, I could simply say what I could write as a part of the conclusion here. The smoking levels are uniform across all education levels, both for males as well as females. This is the kind of statistical interpretation I bring out of this data. All right. So if at all they are dependent, then probably I could have looked at the next set of them. Here also the symmetric measures. If we see the significance levels, all of them are greater than 0.05. So I don't need to even bother about these variables. But even if you see these variables, you are seeing that all the values are much lesser. They should be much higher to talk about a statistically stronger relationship between the two. But here itself I can reject, saying that there is no relationship between the educational status and education level and the smoking status. But even by looking at the values also, these values are significantly smaller, probably again like a zero point 0.4, 0.5 kind of values. They could really say that there is a strength of relationship between the two variables. But here it is very clearly coming out that there is not much of a strength in the relationship. And even the same comes out through the directional measure also, which determines what you are seeing that one here also the significance levels are less than greater than 0.05, so I can very well ignore the dependency relationship that is coming here, and I can very well go with these two variables are independent, whether I look at them gender wise or I look at them overall. There is a clear cut independence that is existing between the two variables, means I can very well conclude that the smoking levels are more or less uniform across the various education levels, even separately for males and females also. That is the kind of conclusion I am able to bring out using this cross-tab analysis. So just as a quick summary, right, we might have discussed most of them, but in case we have not discussed, we'll look at them. So we have seen the frequencies of each of the combinations, and the chi-square test tells whether the differences in the distribution of one variable across the other are real or due to a chance variation. So if the significance level is greater than 0.05, we can say that the differences are not significant. Probably a simple word to use. The differences are not significant, so there is a homogeneity in the proportion across the various groups. So the chi-square test, though it does not tell you the strength of the relationship, we will go to the symmetric measures to identify the strength of the relationship. So the pi, the Cramer V, the contingency coefficient are the various symmetric measures that are there. So at any of these layers, if the significance level is less than 0.05, I could very well say that there is a very strong relationship or there is a significant relationship that is existing between the variables, and then I would look out for the absolute value. If the values are higher to the extent of 50% and more, I could very well conclude that the relationship between the variables is strong. Otherwise, I could conclude that the relationship is weaker. But to determine which one is dependent on which one, I would typically go with a directional measure. So to whichever directional measure, like whichever the directional measure values are much higher, more than zero point 0.5 or so, I could easily conclude that the dependency is more on that dimension compared to the other dimension. Means by knowing that particular variable, the other variable can very well be predicted. That is what comes out as a part of the directional measure analysis. So using the cross tab, basically we can analyze the statistically significance of the relationship between the two categorical variables, probably by layering against one or more variables also. I hope this explanation has given you some decent level of insight into the understanding of cross-tab analysis. If you have any further queries regarding the same, feel free to get back to me on the number that I have given here, or you can even send in an email at vamsidhar@pacegurus.com. I would be more comfortable in terms of addressing your queries. Thanks a lot for listening to this session. Thank you very much.